Apps are boring, of course, only until you add good-looking animations into them. Since Flutter renders everything to the screen itself without relying on those pesky native views, you can animate literally everything. As they say though, with great power comes great confusion. In this tutorial, we will dispel this fog surrounding custom animations and you will finally gain clarity in this matter. Hello, welcome to ResoCoder, where you are getting prepared for real app development by building better, faster, more stable apps. So subscribe and hit the bell if you want to grow your Flutter coding skills. In this tutorial, we are going to do a deep dive into animation in Flutter, and we are going to have an app looking like this by the end of this tutorial. So it will animate a logo of ResoCoder with a bouncing animation, and it's all going to be done in the most basic manner. And then later on in the next part of this tutorial, we're going to refactor the most basic code together into something more clean. But before you can even think about refactoring something, you first have to understand the essence in depth, and that's what this tutorial will be about. And be sure to check out the written tutorial from the link in the description, where you can also find all of the code written in this video and go through it at your own pace. So much of the aforementioned confusion stems from the fact that there are many ways to do the same thing in animation. You can either repeatedly call SetState in a StatefulWidget, you can extend AnimatedWidget, and you can even use AnimatedBuilder. So what's up with these three seemingly different things which still just perform one thing, which is animation in Flutter? Well, in this first part, as I've already said, we're gonna take a look at the most basic option, and that is set state in a stateful regular widget. No animated widget, no animated builder, nothing like that. We first have to understand the basics. Let's first get rid of this default app. You can, of course, get all of this code from the link in the video description. There is the whole project available. And we're going to create an animation page outside of main.dart. Let's create a new file and call it basic animation page. It's gonna be a simple stateful widget, which will be called animation page. Let's import material, of course. And what do we want to do here? Well, we of course want to rotate this ResoCoder logo, and I have added the ResoCoder.png as an asset. You do not need to do that. You can just use your own assets. You can use whatever you like. You can even rotate a regular widget, which is not an image. But in essence, what we want to have in this build method is something which will be able to rotate even without animation. So let's first build the basic UI, which cannot be animated, and then I'm going to explain what animation actually is in Flutter, and that you may be mistaken about the actual essence of animation when it comes to Flutter. So this should not return a container. It will rather return a scaffold, because we are in a page. We want to make it look nice. So return scaffold. And this scaffold will have a body, or app bar will not be present, but a body will be present. And this body has to be able to rotate. And to rotate something in Flutter, we can use a handy transform widget and use the rotate factory, I guess. And we can specify an angle here. And this angle will for now be hard-coded. So for example, 0, which is no rotation. And then its child will be a container which will hold a child, which will be the image asset of ResoCoder. So assets, ResoCoder. You can use any kind of a widget here which you want to rotate, of course. And then this container, just to make it look nice, we're gonna make it aligned to the center. So alignment, and not specify the values directly, but alignment.center. And finally, it's gonna have a padding of edge insets all 30. All right. So now when we take a look at this, this will be basically a regular UI once we import the animation page into main.dart. So it will look like a regular UI without any kind of an animation. All right, here we go. We have the app running, nothing is animated, but when you think about it more deeply, Flutter is built for animation because very much like a game engine, its UI can be refreshed multiple times per second. And actually, we do not even need to do some fancy animation in code. If we wanted to animate this logo ourselves, we could. Of course, when I'm going to click here, the emulator will disappear. But if I input a value of something like 0.5 here and open up the emulator again, the logo will be rotated automatically, right? If I input something like 0.7, it's gonna be rotated even more. If I input something like 3, the rotation will be something different. So we can animate this UI even ourselves by hand without using any kind of fancy code by just changing the angle of the transform. And this is precisely what we are going to do with the animation. And of course, to change something programmatically in the UI and to make the build function run again, we have to call SetState from within the stateful or the state class of the StatefulWidget. So now the only question remains, how can we change the rotation value in a way that provides a smooth animation and that it's done programmatically and that we do not have to write the angle here ourselves by hand? Well, that's what the animation in Flutter is for. And that's where you might have some kind of a confusion when it comes to Flutter's animation. Because at least for me, when I think about animation, I think of things moving on the screen, things jumping and so on, like Disney movie, right? But on Flutter, it's completely different. Animation is just nicely generated, interpolated values multiple times per second. Animation does not move anything itself. Animation just generates some values which can then be used inside the UI. So we would do something like some changing value here. And of course, when this changing value changes and we call setState, the build method will be rerun and the angle will be different. So that's what animation is in Flutter. It's just changing values. All right, now that you know the essence of animation in Flutter, let's jump in and let's do something useful about it. Every custom animation has to have an animation controller. So we're going to create a field in this animation page state of type animation controller called anim controller. And we're going to initialize it. Where else than in the init state method. So we're going to just say that anim controller should be equal to animation controller, a new instance of it. And what does it take in? Well, it has to take in a duration, which is the duration of the animation, which is going to perform, how long it should generate numbers basically. And in this case, we want to have the duration to be 5 seconds. And an animation controller will generate values of 0 to 1 in the specified time span of 5 seconds once we start off the animation. But another important parameter of animation controller's constructor is vsync, which is actually required. And what is vsync? Well, we have to tell this controller how many times per second it should progress toward the final value. You know, screens can have refresh rates of 60 frames per second or maybe even 90 if you are using some OnePlus 7 Pro at the time of recording this video. This is probably the only phone which supports 90 FPS. And to keep the animation smooth, every single time that the screen refreshes, a new frame or a new value in this case has to be generated so that the UI can be updated either 60 or 90 or even 120 times per second if you have a beefy phone in the future. And to let animation controller know when precisely it should generate values, we're going to use a special ticker mixin, and it's a common case to use this mixin on the widget containing this animation controller. So in this case, we're going to use this mixin on the animation page state. And if you want to learn more about mixins in general, definitely check out the video from the card in the corner. We're going to use single ticker provider state mixin, which is optimized if you have just one animation controller, but as it writes in the documentation, if you have multiple animation controllers in a widget, you should use a ticker provider state mixin and not a single ticker provider state mixin. But in our case, we can use this one because we have just one animation controller over here. And now what we can do is to specify vsync and set it to this, because this is now also a single ticker provider state mixin. And actually, let's even right now start off the animation, even though it's not gonna do anything useful just yet because we are not like changing anything in the UI. But still, we can start off the animation by calling forward on the animation controller. So this will make it go from 0 to 1 in the specified time span of 5 seconds, of course. Also, it's extremely important that you do not forget to dispose of the animation controller to prevent any memory leaks. And actually, it's going to throw a bunch of exceptions on you if you do not do this properly. So we have to go somewhere. I like to do it below the build method because it doesn't clutter up the code as much. So we're going to create a dispose method here, and before calling super.dispose, we have to call animController.dispose. This is extremely important. Definitely do not forget to do this. We currently have only an animation controller, but to use the values of an animation inside the UI for the angle, we have to have an animation of double. So it's actually a type. Animation is a type. So it's going to be animation double, and it's gonna be called animation. And then every animation exposes its current value, so we can use it inside the angle parameter of the transform, so animation.value. And as the animation value changes and we call setState, the angle will change. Of course, currently this animation's value will not change because the animation field is not even initialized yet, but we're going to get to it later. So how can we connect this animation with the animation controller, and what's actually going on in here? Well, let's first talk about the animation controller a bit more, because it is actually itself a subclass of animation. Yes, even animation controller can be used directly inside the transforms rotate factory. So we can, instead of an animation, specify here the anim controller and get its value here, and it should actually work just fine. But we probably do not want to do that, because remember that animation controller by default generates values from 0, lower bound, to 1. And we want to have values of something different here, definitely not 0 to 1, because we want to make it a full circle. And 0 to 1 is not a full circle in radians, because full circle is 0 to 2 times pi radians, right? If you know something about these values from trigonometry or somewhere else. So if we open up the definition of animation controller, we can see that it extends animation double. That's why we can use it directly as an animation. But we do not want to do that because we want to modify the range of the values. And we are not going to modify the range of the generated values directly on the animation controller. Instead, we are going to use a tween for that, because tweens make it possible to either change the range from, let's say, 0 to 500 or minus 200 to plus 1000, it doesn't really matter. And they can also change the range to be of a different type than double. You can just as well have a range of colors or a range of text styles which are changing into one another. So really, there is a lot which the tween can do right out of the box. So let's set this animation which we have just created, this field here, below setting the anim controller in init state. And let's set it to be a tween. In our case, we are going to make it a tween double. And of course, you can make it something else because Flutter supports even color tween and textile tween and many other tweens which you can learn more about from the documentation. But we just want to have a simple tween double. And then it takes in a beginning. In our case, it's still going to be 0, but end will be 2 pi. And we have to import the math package from Dart standard library. So math, Dart math, and the end will be math, or actually 2 times math dot pi, because it's a good practice to import it as math. So now we can use it as math.py, but this returns an animatable, or actually a tween, which is an animatable. But we do not want to have an animatable, we instead want to have an animation. And to perform an animation, we're going to call animate and then specify the parent, which in this case will be Animate Controller. So what's actually going on here, because this may be confusing to some people, and I don't blame you, it's been confusing to me. Well, this tween will change the range of the animation, which currently is running from 0 to 1 to 0 to 2 pi, which is like 6.28 something. And it's going to do that completely automatically because it knows that, for example, if the Animate Controller is currently at 0.5, that it's in the half of the animation, and it's going to automatically just generate pi value, so 3.14, because that's the middle of its own range, right? It's going to transform the range to its own. So now what we can do is to go down here and change the rotation or the angle of the transform to come from animation.value. And then all that's left to do is to actually call SetState every single time that a new value is generated by the tween, or even by the Animate Controller, but we can do it directly on the tween itself. So every animation exposes a listener, and we can add a listener here with a cascade operator, and this listener will do nothing else, it will do nothing fancy except for calling empty SetState. We're not going to input anything into this SetState, and that's for a simple reason. It is because the updated value is already present in the animation field. We do not have to set anything in SetState because it's already set. This SetState now has only one function, and that is to cause the rebuilding of the UI by calling repeatedly the build method. This is one of the things which we are going to refactor in the next part. So definitely subscribe and also hit the bell if you do not want to miss it. What this means now is that if we open up the emulator, and actually we will have to perform a hot restart, so Control-Shift-F5, I hope so, yeah. So now it's animating, right? But it's kind of a boring animation. It doesn't have any bounciness or anything like that. And also it stops after just one time of it being rotated. So let's see it once more. And sure, it animates again, but again, it will stop once the animation finishes. This happens because we are calling only AnimatedController.forward, which performs the forward animation by making the AnimatedController generate values from 0 to 1. But we can also make it generate values from 1 to 0, so it will go back. And this is possible by making it call not forward, but reverse. We can make this animation loop infinitely by using another kind of a listener, and that is status listener. So let's add status listener, and this will take a status here, which is an enumerated type, and it can be either dismissed, so it's stopped at the beginning, forward, which is animating in forward direction, completed, which is stopped at the end, and reverse. What interests us in particular is the animation status.completed, because if something like that happens, so status is equal to animation status.completed, this means that the animation finished at the end. And in that case, we want to call anim controller dot reverse because we want to make the animation run backwards. But otherwise, so else if the status is animation status dot dismissed, which simply, even though it says dismissed, it just means that it's stopped at the beginning of the animation. So the anim controller is at the value 0. Then we want to again perform the forward animation. So we're going to call anim controller dot forward. And still we have to call anim controller dot forward even outside of the status listener, because otherwise the first animation will not start and the status listener will not be called, so it will be just stationary. If we now refresh the UI by doing hard restart and wait for a while, we will see that actually it starts animating backwards and forwards, and it's gonna do that infinitely. But as you can see, all of the animations are linear by default, and this means that their speed is constant no matter at which stage of the animation they are in. So if they are at the beginning or at the end, they are still animated at the same speed. But we can change this by adding curves to the animation. So for example, we can make it bounce in and ease out. And this is very simple to do in Flutter. We are going to first define a curved animation right above the tween, where we are setting the tween. Above this, we're going to make a final curved animation. And it's going to be equal to a new instance of curved animation. And this takes in a parent, which will be the anim controller. And it actually doesn't have to be a controller because this parent is of type animation double. So it can be really any kind of an animation double, not just the controller. And then also we can set a curve here. So this is the forward curve, and we want to make it a curve dot or curves dot bounce in. And the reverse curve can be set separately from the forward curve, and this will be curves dot, and let's say ease out. And then we can animate this tween for rotation, not by using anim controller anymore, but instead we're going to plug in the curved animation in here, because this animate again doesn't take in an animation controller, it instead takes in an animation double. And sure enough, our curved animation is animation double. If we take a look at it, it extends animation double in its definition. So what we've done here is layering or nesting of animations, and this is possible to do basically an infinite amount of times. So you can really create some nifty looking animations by just layering them on top of each other, like we've done here with this curved animation. So now once we refresh the UI or hard restart it and go here, we can see that it's bouncing at the start, and then it just eases out and starts bouncing again. Once it bounces completely, again it eases out, and it will do this infinitely. I'm just gonna show you another approach of adding curves to the animation, and just know that this is really useful, especially if you want to have different curves for the forward animation and for the reverse animation. But if this is not needed, you can do something. It's not really even simpler, but it's just a different way of adding curves. And that is, if we actually comment this out, we can use another tween, which will be a special type of tween called curve tween. And we can chain multiple tweens together by calling chain on a tween. So we're going to call chain, and we're going to chain a curve tween, our curve tween. And this takes in only a single curve, which we will set to curves bounce in. And then we're going to pass again the animation controller itself, because we no longer have an curved animation here. So once we do that, and now we refresh the UI by hard restarting, the curves will be identical for forward and backward animation, but we've added them in a different way by using a tween and not by using a curved animation. So if you just want to have the same curves all the time, this is another option how to do this. But I actually like the previous version much better, so I'm just going to hit Ctrl-Z a bunch of times so that we again have a nice curved animation with different curves at the beginning and at the end. In this tutorial, you gained an understanding of animations in Flutter. You now know how to create fully fledged animations using the classes which Flutter provides. The code which we have currently though is quite messy, and a little separation of concerns will surely help the code reuse and also with readability. And so in the next part, you will learn how to use the AnimatedWidget and AnimatedBuilder to refactor your animations so that you can actually even unentangle the animation from the UI itself. Because currently we are somehow joining the animation with the UI because we are hard coding the animation value inside here. This UI would not work if the animation was not present. So you're gonna learn how to separate out your code so that you can reuse the animation multiple times on multiple different widgets. And if you do not want to miss this next tutorial and also many more tutorials on Flutter and Dart, definitely subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter coding skills, because here on ResoCoder, I am determined to provide you with the best app development tutorials and resources out there. If this video helped you to understand animations more in depth, definitely give it a like and also share it with other developers who will surely benefit from this. Follow me on Instagram, I go under the name ResoCoder everywhere. Leave a comment if you have any suggestions or questions or anything else to say, and see you in the next video.